Good afternoon, students. In last lecture, we are studied how to calculate oxidation number of atoms in a molecule. In this lecture, we are going to study balancing of redox reactions. There are two methods for balancing of redox reaction. First method is oxidation number method, and second method is ion electron method. In this lecture, we are going to study how to balance redox reaction by using oxidation number method. There are some steps involved in balancing of redox reaction. First step is write unbalanced equation, then balance all atoms except hydrogen and oxygen. This is the first step, that is write unbalanced equation and then balance all atoms except hydrogen and oxygen. Then second step is assign oxidation number of all atoms in both reactants and products. That means in unbalanced equation, write oxidation number of all atoms in the reactants and products, so as to we can determine which species undergoes oxidation and which species undergoes reduction. We know that oxidation is the increase in oxidation number of any species, that is called as oxidation, and decrease in oxidation number of any species, that is called as reduction. Then what is the second step of the balancing of redox reaction is the assign oxidation number of all atoms in both reactants and product, so as to we can determine which species undergoes oxidation and which species undergoes reduction. Then third step is identify atoms that have changed oxidation number and by how much. Then next step is determine factor that will make total increase in oxidation number and total decrease in oxidation number are equal. Then insert the coefficient in the redox equation. Then next step is balance oxygen atoms by adding water molecules to the side containing less oxygen number. Suppose if in the reactant side one oxygen is less as compared to product side, then add one water molecule to the reactant side. Similarly, if two oxygen are less in the reactant side than product side, then add two water molecule to the reactant side. In this way, we can add number of water molecules that are less in either side of the equation, either reactant or product side. Then next step is balancing of hydrogen. How to balance hydrogen in the redox equation? By calculating number of hydrogen atoms in both sides, then add H+ ion to the side containing less hydrogen atom. If at the reactant side one hydrogen is less as compared to product side, then add one H+ ion to the reactant side in this way. Then next step is if reaction occurs in basic medium. If reaction occurs in basic medium, then add hydroxyl ion, that means OH- ions to the both sides of the equation, that is from reactant side and in product side. But this rule is for only reaction which occurs in basic medium. And last step is then check the balance equation with respect to all atoms and charges. Our equation will be balanced with respect to atoms and charges. Then by using these steps, we can balance any redox reaction by oxidation number method. Then we are going to start first example. Balance the following redox reaction in acidic medium by oxidation number method. Our question is balance following redox reaction by oxidation number method which occurs in acidic medium. Then what is the reaction? I will write here. MnO4 minus in aqueous state plus SO3 minus 2 in aqueous state. It gives MnO4 minus 2 aqueous state plus SO4 minus 2 in aqueous state. This reaction occurs in acidic medium. This reaction we have to balance by oxidation number method by using rules or steps. First step is step first. Write unbalanced equation. Step first. Write unbalanced equation. Write unbalanced equation and balance all atoms other than hydrogen and oxygen. First of all, here number of atoms other than hydrogen and oxygen are sulfur and manganese. In reactant side there is one Mn atom. In product side there is also one Mn atom. That is, atoms other than hydrogen and oxygen are already balanced. Then next atom other than hydrogen and oxygen is sulfur. Reactant side one sulfur is present and product side there is also one sulfur is present. That is, first step is completed. That means all atoms other than hydrogen and oxygen are already balanced. Then we are write unbalanced equation. MnO4 minus plus SO3 minus 2. It gives MnO4 minus 2 plus SO4 minus 2 aqueous. Then step second. What is the step second? Step second is assign oxidation number of all atoms in both reactants and products. In short, assign oxidation number of all atoms in reactant and product side. Then we are going to assign oxidation number of all atoms SO4 minus 2 aqueous. Here we know that according to rules for calculating oxidation number, oxygen generally shows minus 2 oxidation state. Therefore, oxidation number of oxygen is minus 2. Then, what is the oxidation number of Mn in these species? Mn, suppose oxidation number of MnO4 minus, suppose X 4 oxygen atom, therefore 4 multiplied by minus 2 is equal to charge on the molecule. X minus 8 is equal to minus 1, X is equal to minus 1 plus 8, that is plus 7. What is the oxidation number of Mn plus 7? Then next is similarly oxidation number of sulfur plus 4, oxygen minus 2. In this case, oxidation number of Mn plus 6 and oxygen minus 2. Oxidation number of sulfur plus 6, oxygen minus 2. This is the step second. We are already determined oxidation number of all atoms. Oxidation number of manganese is changes from plus 7 to plus 6, that is decreases. It indicates that Mn undergoes reduction. Oxidation number of oxygen minus 2, minus 2, minus 2, minus 2. It does not changes. That means oxygen does not undergo either oxidation or reduction. Then oxidation number of sulfur, in a reactant side it is plus 4, in product side it is plus 6. That means oxidation number of sulfur increases from plus 4 to plus 6, that is by 2 units. Then next step is identify atoms that have changed oxidation number. Step third. Identify atoms that have changed oxidation number. Identify atoms that have changed oxidation number. Oxidation number. This reaction indicates that oxidation number of sulfur changes from plus 4 to plus 6. That means it undergoes oxidation. Therefore, oxidation number of sulfur increases from plus 4 to plus 6, that is by 2 units. And oxidation number of manganese decreases from plus 7 to plus 6, that is by 1 unit. Then here we identify which species undergoes oxidation and which species undergoes reduction. This equation indicates that sulfur undergoes oxidation and manganese undergoes reduction. The next step is determine factor that will make total increase and decrease equal. Step 4. Step 4. Determine factor that will make total increase in oxidation number and total decrease in oxidation number will equal. That means here oxidation number of sulfur increases by 2 units and oxidation number of Mn decreases by 1 unit. Therefore, by multiplying 2 to Mn, then oxidation number of Mn decreases from plus 7 to plus 6. By multiplying it 2, then total increase and decrease becomes equal. That means in equation we have to insert coefficient, that is 2 in the equation. Here manganese is present. That means multiplied by 2 MnO4 minus plus SO3 minus 2, it gives twice MnO4 minus 2 plus SO4 minus 2 aqueous. By inserting coefficient 2 in the reaction in which Mn, by multiplying by 2 to Mn, that will make total increase in oxidation number and total decrease in oxidation number will equal. Then next step is step 5th, balancing of oxygen. Balancing of oxygen atoms. How to balance oxygen? First of all, calculate number of oxygen atom in reactants and products. Count 4 multiplied by 2, 8. 8 plus 3, 11. At left hand side there are 11 oxygen are present, that is reactant side. In product side, 4 multiplied by 2, 8. 8 plus 4, 12. On reactant side there are 12 oxygen atom. What is the rule? Balance the oxygen atom by adding water molecule to the side containing less oxygen atom. Therefore it indicates that towards reactant side 1 oxygen is less. Therefore we have to add one water molecule to the reactant side. That will make total oxygen becomes equal. Then twice MnO4 minus plus SO3 minus 2 plus 1 water molecule liquid. It gives twice MnO4 minus 2 plus SO4 minus 2 aqueous. Now, step 6. Here, oxygen are balanced. In the left hand side, there are 12 oxygen atom, and right hand side there are also 12 oxygen atom. Next step is balancing of hydrogen. Step 6. Balancing of hydrogen. Hydrogen atoms. How to balance hydrogen? First of all, calculate number of hydrogen atom in both sides of the equation. Then add H plus ion to the side containing less hydrogen atom. Left hand side, that is towards reactant side, there are 2 hydrogen atom, and in product side there is no any hydrogen atom. Therefore, product side containing 2 less hydrogen atom. Therefore, we have to add 2 H plus ions to the product side. Twice MnO4 aqueous plus SO3 minus 2 plus water liquid 2 for 2 MnO4 minus 2 plus SO4 minus 2 plus 2 H plus aqueous. Now, hydrogen and oxygen are balanced. Towards reactant side, there are 2 hydrogen atoms, and product side there are also 2 hydrogen atoms. Then, last step 7. Step 7th is observe the equation. You want check equation with respect to all atoms and charges, that will balanced. Reactant side 2 Mn, product side 2 Mn, that is manganese. 1 sulfur, 1 sulfur. That is manganese and sulfur are already balanced. Then number of oxygen, 4 multiplied by 2, 8, 8 plus 3, 11, 11 plus 1, 12. Reactant side there are 12 oxygen atoms are present. Product side 4 multiplied by 2, 8, 8 plus 4, 12. That is oxygen are balanced. Then hydrogen, reactant side 2 hydrogen atoms are present. Product side there are also 2 hydrogen atoms are present. That means reaction is balanced with respect to all atoms. But what is the charges? Charge on reactant side 2 multiplied by 1 minus 2, 1 multiplied by minus 2 minus 2, and water has no any charge. Therefore total charge on reactant side, that is minus 4. Then product side 2 multiplied by minus 2 minus 4, 1 multiplied by minus 2 minus 2, and 2 multiplied by plus 1 plus 2, plus 2 minus 2 get cancelled, remaining is minus 4. That means charge is already balanced. Minus 4, minus 4. Therefore, reaction is also balanced. Then balance equation. Twice MnO4 minus SO3 minus 2 plus water liquid, it gives twice MnO4 minus 2 aqueous plus SO4 minus 2 aqueous plus 2H plus aqueous. This is the balance equation by oxidation number method. Then in next lecture we will discuss reaction in basic medium.